This video will review over how to identify the various chemical reactions associated with acids and bases. Now remember that an acid is a chemical compound that begins with hydrogen, and a base is a chemical compound that has OH. Our acids and bases react together to make salt and water, and we want to learn how to determine what exact salt is formed if we're given a parent acid and a parent base. Remember to refer to your list of strong and weak acids to determine if an acid is strong or weak. And for bases, you want to look at your cation, or your first element in the equation. If the element is in group 1 or 2 from the periodic table, then the base will be strong. If the element is not in group 1 or 2, then the base will be weak. In chemical reactions of acids and bases, compounds with acidic properties and compounds with basic properties often will react with one another. One of the major similarities is that in each type of reaction listed, one of the products will be salt. In a chemical reaction where we have an acid reacting with a base, we have salt and water as our two products. Now, to determine the specific salt that occurs, we must first look at our acid and our base. Now remember that an acid always begins with hydrogen and a base has OH. To determine whether the acid is strong or weak, refer to the list that you were given in class. To determine whether the base is strong or weak, look at the element that is the cation, or the positive charge. If this element is in group 1 or 2 on the periodic table, then you have a strong base. If not, it is a weak base. Sodium is in group 1, therefore this is a strong base. Now the way we determine what the product is that our positive on our acid, which is our hydrogen, and our negative from our base, which is the OH, come together. And when we have HOH, that makes water. What is left over becomes our salt. Now since sodium is positive, it will go first. Chlorine is negative, it will go second. We do have to remember that sodium has a +1, chlorine has a -1, crisscross, and we get NaCl. On this problem, notice that we have aluminum hydroxide plus hydrochloric acid. Now to determine what we have for our results, we would take our aluminum and we would take our hydrogen, and they would trade places. So our hydrogen and our OH come together and we get HOH. And then our aluminum and our chlorine come together. Aluminum has a +3, chlorine has a -1, crisscross, and so we would have AlCl3. We have on B, barium hydroxide plus acetic acid. Our OH and our hydrogen trade places here. We get that joined up. Our barium joins with our acetate. Now that's on Fat Daddy. Barium has a +2 charge. Acetate is C2H3O2. It has a -1 crisscross, and we get our salt. Here on C, we have potassium hydroxide plus sulfuric acid. Remember, our OH and our H combine up, so we get our water. Our potassium joins with our sulfate. Potassium has a +1 charge. Sulfate from the periodic table has a -2. Crisscross, we get K2SO4. Now, when we look at D, D does a little bit of a strange combination, and I would not put this on the test. However, we end up with an NH4 plus our OH. This is not a true acid-base reaction where we have our acid and our water. When we look at reactions of acids, acids react with many metals. And when an acid reacts with a metal, it is a single replacement reaction with salts and hydrogen gas being given off. So if we looked at an example of zinc plus hydrochloric acid, we would have a single replacement reaction where our zinc would join with our chlorine. And so we have zinc with a +2 charge, chlorine with a -1, and we would have H2 because hydrogen is diatomic. Let's look at a few additional examples. Now here we have magnesium plus hydrogen chloride or hydrochloric acid. Now magnesium has a +2 charge, hydrogen has a +1 charge, chlorine has a -1. So what we have is our positive charged elements trade places. Therefore, we end up with hydrogen gas, remember hydrogen being diatomic, and we have magnesium chloride. Magnesium has a +2, chlorine -1, crisscross, we get MgCl2. Here we have zinc plus nitric acid. The hydrogen and the zinc will trade places. We get H2. Zinc here has a +2 charge. Nitrate has a -1, crisscross, and we get our answer. In our third example, we have aluminum plus hydrobromic acid. The hydrogen and the aluminum will trade places, so we get our H2. Remember, aluminum has a +3 bromine, -1 crisscross. We get AlBr3. Here we have an acid that reacts with a metal oxide. The product will be salt and water. So as we look, our positively charged copper, our positively charged hydrogen will trade places. Copper has a +2, sulfate has a -2, crisscross, we get CuSO4. We have our hydrogen joining with our oxygen, and that would make our water. Remember, if you're not sure that it would make water, go back and check your charges, as hydrogen has a +1, oxygen -2, crisscross, it would give the H2O. Acids can also react with carbonates. The product are a salt, water, and carbon dioxide. In this example, we have calcium carbonate reacting with hydrochloric acid. Now our calcium and our hydrogen will trade places. Calcium has a +2, chlorine has a -1, crisscross, we get our CaCl2. When we look at our hydrogen will join with the oxygen to make our H2O. That leaves one carbon and one oxygen for our carbon monoxide. When a hydroxide reacts with a nonmetal oxide, the product will be either salt or salt and water. Now this depends upon the quantity of the reactants. So as we look at this, when we have a 1:2 ratio, we will make our salt plus water. If we have a 1:1 ratio, then we will just have our salt that's formed. And so this would be a synthesis reaction right here, while here we would have a replacement reaction. One of the things that we do have to do is, in some of these cases, such as the hydroxide, is to memorize what goes on. So the 1 to 2, the salt and the water, the 1 to 1 would be the salt. And unfortunately, that's just the nature of some of the reactions, is memorizing the trends. A few additional reactions that need to be studied and memorized include oxidizing reactions. These are reactions in which atoms of elements lose one or more electrons and attain a more positive oxidation state. The most common oxidizing acids will be hot concentrated sulfuric acid, nitric acid, and chlorine-containing oxyacids. We will be concentrating on the sulfuric acid and the nitric acids on these next few slides. Hot concentrated sulfuric acids react to form hydrogen sulfide and water. Now in this reaction we have zinc plus sulfuric acid. We will have zinc sulfate formed, hydrogen sulfide, hydrogen plus 1, sulfide negative 2, and water. Now this is a trend that occurs, and it's one you'll need to study and memorize. With regard to nitric acid, there are several different products that can form. This is dependent upon the concentration of the acid. Now a dilute concentration will produce nitrogen-containing product, nitrogen monoxide, and water. Let's look at an example. Here we have copper plus dilute nitric acid. The copper will trade places with the hydrogen. We will form copper nitrate, copper plus 2, nitrate negative 1, crisscross. It will also make nitrogen monoxide and water. Now with concentrated nitric acid, the results are nitrogen-containing product, nitrogen dioxide, and water. Notice in this example everything is exactly the same as far as our reactants are concerned, with the exception that nitric acid is written as concentrated. On the previous slide, nitric acid was written as aqueous, and aqueous means dilute. Because we have concentrated nitric acid, we will still make our copper 2 nitrate. We will still make our water. The difference is, with concentrated, we make nitrogen dioxide, and with dilute, we make nitrogen monoxide.